Bismillahirrahmanirrahim. Class pre-9. We are doing unit number 1, matrices and determinants. And this is our session number 5. In last session, we have discussed types of matrices and its definitions. And now in this session, actually this is the implementation, or you can say that application of these definitions. And we are going to solve exercise 1.2 with the help of these definitions. Exercise 1.2, question number 1. From the following matrices are given, and you are going to identify what are unit matrices, which of them are unit matrices, row matrices, column matrices, and null matrices. Look at the first part of this question number 1. Matrix A is given, and its entries are 0, 0, 0, and 0. All entries are 0. So, matrix A is a null matrix, as all of its entries are 0, and we are familiar with the definition that null matrix is a matrix in which all the entries are 0. So matrix A is a null matrix. Next, again the same question, part 2. Matrix B is given, and its entries are 2, 3, and 4, and these entries are just in one row. Matrix B, these entries. Matrix B is a row matrix, as we know that if a matrix have only one row, then that matrix is a row matrix. So B matrix having only one row is called a row matrix, and its identification of B is this is a row matrix. Next, the same question, part 3, matrix C, and you can see that its entries are written in one column. It is only one column. So the matrix C is a column matrix, as we know that if a matrix having only one column, it is a column matrix. So matrix C is a column matrix. Again, same question, identify which of them are unit matrices, row matrices, column matrices, and null matrices. And matrices are given. Matrix D, and you can see the entries 1, 0, 0, and 1. And look at here, it's diagonal entries. Diagonal entries are 1 and 1, and all other entries are 0 and 0. So diagonal entries are 1. Matrix D is a unit matrix, as its diagonal entries are 1 and all non-diagonal entries are 0. So this matrix D is a unit matrix, and we know that unit matrix is also called identity matrix. Again, same question, we are going to identify. Look at here, matrix E, and its entry is 0. Its order is 1 by 1, and all the entries are 0, as it has only one entry, that is 0. So matrix E is a null matrix, as its all entries are 0. So E is a null matrix. Again, same question. Question number 2. From the following matrices, identify square matrices, rectangular matrices, row matrices, column matrices, identity matrices, and null matrices. Matrices are given, and we are going to identify what type of this. Part 1 of question number 2. Matrix is given, and its entries are -8, 2, 7. This is first row, and 12, 0, and 4. This is second row, and it has 1, 2, and 3 columns. As definitely it has 2 rows, so this is not a row matrix. It has 3 columns, so this is not a column matrix. And also this is not a square matrix, as square matrices are those matrices in which number of rows is equal to the number of columns. So this is not a square matrix also. Identity matrices, as identity matrices should be square matrices. So this is not a identity matrix. Null matrix. Null matrix is a matrix in which all entries are 0. So this is not a null matrix. Matrix that is given here, this is a rectangular matrix. Rectangular, as its number of rows and columns are not equal. So this matrix is a rectangular matrix. This is its type. Next. Question number 2. Identify these. Part 2. Look at this matrix. Its entries are 6, -4, 3 and -2. It has 1 and 2 rows, 1 and 2 columns. So its order is 2 by 2. Also this is not a row matrix, not a column matrix, not an identity matrix, as diagonal entries are not equal to 1. So this is not an identity matrix. This is also not a null matrix, as all entries are non-zero. So this is not a null matrix. Not a rectangular, as number of rows equal to number of columns. So this is a square matrix. Matrix is a square matrix, as its number of rows and columns are equal. Question number 2 again. Identify. Part 3. Look at this. Matrix 1, 0, 0 and 1, having 1 and 2 rows, 1 and 2 columns. So its order is 2 by 2. You can say this is a square matrix, but again, look at here. It's diagonal entries. Diagonal entries are 1 and 1. And we know that if diagonal entries are 1 and 1, so this is a identity matrix, and all other non-diagonal entries are 0. So matrix is a identity matrix, as its diagonal entries are 1 and all other entries are 0. So this matrix is a identity. Next, question number 2, same question. Identify. Part 7. Look at here. 1, 0 and 0. This is a matrix and it has 1, 2 and 3 columns, 3 rows, and it has 1 column. So this is not a square matrix, as its number of rows is not equal to number of columns. You can say that this is a rectangular matrix. Also this is a column matrix. Okay, but this is not an identity matrix and not a null matrix. So this matrix is a column matrix, as it has its main specification is this, that it has 1 column only. So this is a column matrix, as it has only 1 column. Next, again same question number 2, part 8. Look at this matrix. It has 1, 2 and 3 rows and 3 columns. Its order is 3 by 3. Also its diagonal entries are these diagonal entries, and definitely these are non-zero, but other entries are non-diagonal entries are not 0, as this is 2, this is 3, this is -1, 0 and 0. So what is this? Matrix is a square matrix, as it has equal number of rows and columns. So this matrix is a square matrix. Question number 2. Identify. Part 9. Look at this. All entries are 0. All entries are 0. Also it has 1, 2 and 3 rows, and 1 and 2 columns. Its order is 3 by 2, as 3 by 2. So this is not a square matrix, but all the entries are 0. So this is a null matrix. Matrix is null matrix, as its all entries are 0. Next, question number 3. From the following matrices, identify diagonal, scalar, and unit. And we know that unit matrix is also called identity matrix. So matrices are given and we are going to sorting out which of them are diagonal, which of them are scalar, and which of them are unit or identity matrices. Look at the first matrix A. Its entries are 4, 0, 0, and 1. And now this is a square matrix definitely, as its order is 2 by 2, 2 rows and 2 columns. And its diagonal entries are these 4 and 4. And diagonal entries are same, equal to each other, also not equal to 0 and 1. So if the diagonal entries are same and not equal to 0 and 1, then matrix is scalar matrix and its diagonal entries are same and other than 0 and 1. So this is a scalar matrix. Next. Again, question number 3. Identify part this B. And here B matrix. And its entries are 2, 0, 0, and -1. And its diagonal entries are these. And diagonal entries are 2 and -1. And non-diagonal entries are 0 and 0. So all non-diagonal entries are 0 and diagonal entries are 2 and -1. As diagonal entries are not equal to 1, so this is not an identity matrix. Matrix is a diagonal matrix as its diagonal entries are non-zero and all other entries are 0. So this matrix B is a diagonal matrix. Next, question number 3. Again, identify. Look at this matrix C and its diagonal entries are 1 and non-diagonal entries are 0. So diagonal entries are 1 and 1 equal to each other, also equal to 1. And non-diagonal entries are 0. So this matrix C, look at here, matrix C is unit or identity matrix as its diagonal entries are 1 and all other are 0. So matrix C is a unit or identity matrix. Question number 3, look at here, matrix T. And now its diagonal entries are here 3 and 0. And all non-diagonal entries are 0. And we know that what is the definition of diagonal entries? Matrix. A diagonal matrix is a matrix in which diagonal entries, at least one of them is non-zero. So this matrix T is a diagonal matrix as its at least one diagonal entry is non-zero and all other entries are 0. So matrix T is a diagonal matrix. Again, question number 3, identify, look at here, matrix E. And its entries are here now. These are in the form of binary operations, 5 minus 3. And we know that 5 minus 3 is equal to 2. 1 plus 1 and 1 plus 1 is equal to 2. This is its diagonal. And diagonal entries are 5 minus 3, 2. 1 plus 1, 2. And non-diagonal entries are 0 and 0. Diagonal entries are equal to 2 and 2. Both are same. And non-diagonal entries are 0. So matrix is scalar matrix as its diagonal entries are same other than 0 and 1 and all other entries are 0. So this matrix E is scalar matrix. Now I hope students you can solve these questions very easily. Fi Aman Allah.